Hey everybody, this is Larry. This is me going with bi-weekly contest 60, number Q4, the number of good subsets. Hit the like button, hit the subscribe button, join me in Discord, especially if you like contest problems, and let me know what you think. So one disclaimer I have for this one is that I actually solved in Java. It's not necessary, but I did some mental calculations that was wrong, and I'll talk about that later, but let's focus on the problem. So the first thing to notice is that you should look at constraints for these things. Well, the first thing I noticed is that, there's a mod, so you should consider the mod. I did. But then the next thing is the constraints, right? One is that n is 10 to the 5th, so it's hard to do brute force on that, or is it? But the second, because is that the number sub I is 30. That means that every number is less than or equal to 30, right? So that's basically the basis for this problem is that, okay, that means that the number of primes, there are only 10. So I actually looked this up because I was too lazy to code something up. I Googled this, the first n primes, and then I saw this list. I was like, okay, so there are 10 primes on the 30, right? So that means that, and because in this case you want distinct, really poorly phrased if you ask me, but that means that every prime number can only appear once in some way. So that means that essentially there's 2 to the 10 different possible products, right? Because that means that for every possible product, it only takes either 0 or 1 of each of these possibility, which lends itself to a bit mass solution. So making this observation is good enough for me to get working on it, because then now I can process each number using dynamic programming, and I'll go over that in a second. But this gives me an idea, right? I kind of do some additional pre-processing, which we'll talk about in a little bit. But basically, the idea here is, let me actually pull up my other solution, because I have a TLE solution that I like in terms of progression. Why is this accepted in red? Is that seems okay? It turned into green. That's a little bit scary actually for a second, because I'm still during contest time. So, but yeah. So this is my original time limited exceeded solution. But basically, the idea here is that, okay, for each number, so this is a bitmask solution. I'm going to say that for this problem, the prerequisite is a bitmask. If you're not familiar with bitmask, maybe go over with some of my early other videos, especially with dynamic programming. I think I have a couple of good ones for dynamic programming and bitmasks. I could post some in the link below. But I don't want to go over it here because it'll just take too long. And I don't want to go over the same basic details every video that I do, so I apologize for that. But yeah, let's say you do, right? And there are a couple of cases that you have to consider. One is that, but basically the idea is that, okay, let me pull up Paint real quick so that I can draw some things for you. But basically the idea is that, okay, bitmask is just some TF, is a Boolean lookup thing, right? So then here, the idea about my bitmask is that, okay, let's say this is your previous state, and I'm too lazy to draw out all the numbers. So pretend that this is 2, 3, 5, 7, 11, 13, and 17, right? That means and here our bitmask represents 2 times 5 times 11 times 13 times 17, right? And this is because these are the t values, the true values, right? So this goes here and so forth. And then that means that, so basically we here keep track of the number of counts that we can do this. And this is, of course, just the number of this is just the number of 2s and 5s and so forth, right? If they're all primes. And then now, how the next number, if the next number is a 3, for example, then what does this mean, right? That means that well, we have some count here. I don't like the number, the red. So we have some x, which is the number of count of this product, right? So then now, if we add a 3 here, what does that mean? That means that, what is the number of ways to do this thing, right? 2 times 11 times 13. I'm drawing these with the mouse, so it's a little bit slow. But so now, we let's say we wanted to get this count, and that we're processing a 3. Right? Then that means that now the new state, so let's actually call this x sub I, and then now this is x of I plus 1, maybe, of I for index. This is x and 3, plus a 3, say. I mean, plus is not the addition, but yeah. So this count is going to be the number of this count plus the number of the previous count, right? So yeah, so basically now that you process a 3, you just add the number of ways to do that, right? So in put it another way, and I'm going to get rid of this for a second. So basically, for example, I cannot edit this here quite yet. Technical difficulties, hang on. This is my TLE solution. So you can say that, for example, like I was saying before, you have, f of 2 times 3 or 2 times 5 times 7 times 11 times 13 is equal to some number. Let's say there are 20 of them, right? 20 ways to do this. Then f of, and now let's say we're processing a 3, and we want, what does that mean, right? That means that this is just equal to this number that we are processing, plus the previous version of this. So let's just call it this, because I'm too lazy to change notation. But basically, it's just this plus the previous notation of this. And put it another way, though, it is just this plus this times that but basically this is just equal to the previous way, which is 20, plus this, which is this is 20, because that's the number of ways to kind of have these product. And here is the number of ways that we used to have it, right? Before we process this number, so that if we so basically, given that we're processing a 3, we can either use this 3. If we use this 3, then the previous product has to be, so let's say we're processing, we're processing a new number 3, we have this number. If we use this 3, so this is the state, or this is the product. If we use this 3, then the previous product have to be this minus the 3, so it has to be this, right? Or if we don't use this 3, then the previous product is just the same, right? Which is this thing. So then now we just sum the number of counts. So that's basically the idea behind this one. So then you do this for every number, and note that because there are only 10 possible primes, you can actually try it for every possible product. So that means that, let's say we're processing a 3, right? What does that mean? That means that we can try product is equal to 3, product is equal to 6, and so forth. And of course, in this case, previous product is either equal to 1, or product is 3 because we don't use it. And in this case, previous product is equal to 2, or product is 6, right? and then you kind of dot this. You do it for every product that has a 3 in it. So, and there's only at most 2 to the 10 of these, because these have to be distinct, right? Because, for example, 9 cannot be here because that includes 2 3s. So that's basically the idea. And it becomes a sort of a digit sum dynamic programming. And yeah, and I just kind of pre-process the ones that are not possible, because these because for example, this have 2 2s, this have 2 2s, this have 2 2s as well. So all these have 2 2s, or these have 2 2s, these have 2 3s, and this have 2 5s, and these are all the numbers that are less than 30. That's no good. I was going to write a function about it, but then I was like, okay, there's actually not that many, so let's pre-process this. Yeah, and then here, yeah, we just put it in a Boolean array, so that's easy to look up. And then, so one more thing that I didn't talk about is that I didn't count ones, because you can think about ones as that for every one, you can put in them 2 to the, so let's say you have 10 ones, you can actually, you know, do some permutation of the 2 to the n versions, or let's say the x ones, then there are 2 to the x ways to kind of add that to the existing answer, right? Because, you know, that's the number of combinations. So that's basically, so we keep track of the number of ones, and then otherwise, if this is a good, meaning that it, if this is not no good, do I use good? I actually don't end up using good. Yeah, because I end up doing this. So I actually don't use this. Whoops. But yeah, if this is good, and what does that, it means to be good, when it gets here, that means that is a product of distinct primes, or product of primes that only appear once. So then now we get the bit mask for that product. So if this number mods this prime is equal to 0, then, you know, we do this thing. And then here we look at every bit mask and do a dynamic programming, as we talked about, right? Basically, if the count is greater than 0, meaning that if it contains at least one number, meaning that it exists before, and that there's no overlap. Basically, this is just a bit mask, you know, Boolean n of, okay, if there's overlap, then this is no good. So if there's no overlaps, meaning the overlap is 0, then we just set the mask to be +1, or plus this previous number, and then we mod it, of course, because of the mod. And then that's pretty much it. And then for each ones, we multiply it by 2 at the very end. So how does the math work here, right? So the math is such that, okay, this loop is O of n, and each loop does 2 to the x operations, where x is equal to 10 because n is because 30 is, there are only 10 primes, right? So this is in total O of n times 2 to the x, where n is equal to 100,000 and times 1,000. So this is roughly 100 million. To be honest, I thought this would be fast enough, but not in Python, so I changed it to Java. That's basically the idea why I did it in Java. The reason why this failed in a time limit exceeded kind of way is because the reason why I did it in time limited kind of way is, and you can watch me do this during the contest live, but during the contest, you can see that for each of these, it takes at most 1 second in the worst case. But Leetcode actually does calculate time limit exceeded with respect to the sum of the execution time, right? Not just execution time. So as a result, so if there are 20 test cases, it may fail. If there are 5 test cases, it may pass, right? So that's why my code time limited. And I suspect that a lot of top people probably did it that way initially and then saw it fail because of that reason. So there is one more optimization that I end up doing as a result, which is that But yeah, that's why I submitted, and that's why I converted this from Python to Java, because I thought that 100 million may be fast enough in Java, but not fast enough in other languages. But I was wrong; it wasn't fast enough anyway. But there's one more optimization: is that noting that again, num sub I is equal to 30. So that means that you don't have to process all 10 to the fifth. Or you have to, but you don't have to do them one at a time. You could combine them in a way. So that's basically what I did here, is that I put them in counts. I put them in counts so that they're only 30 numbers. And then here, now if you look at this is just at most O of 30, or X if you want to call it that. And each one, of course, does 2 to the X. So this is now O of X times 2 to the X, where X is equal to 10, and X is number of primes, right? So yeah, so this is the same formula, and then I also do this thing with ones, which if you do mod power, you can do it without this, but I didn't have to do mod power because this is at most 10 to the fifth anyway, right? So it's just another for loop. So this is this part of the algorithm, but of course, in total complexity, because we have to look at each number at least once here, so this is going to be O of n plus X times 2 to the n 2 to the X, and this is going to be fast enough. And in terms of space, this is the most thing, so this is 2 to the 10, so that means that this is 2 to the X space, or O of 2 to the X space, where X is number of primes. Do I actually have this lookup table, as I said. Again, this is not necessary, but yeah, I have this lookup table, but you can actually just put it in a hash table. If you put it in a hash table, then I guess that's what I did here, but I just put it in a Boolean table. If you put in a Boolean, you put in a hash table, this will be O of X space anyway, so it's not, so even though this looks awkward, it is not actually true. But yeah, so this is time, and this is O of 2 to the X space. But yeah, let me know what you think about this one. It's kind of a tricky one, but yeah, let me know what you think. Hit the like button, hit the subscribe button. You could watch me solve it live during the contest next, including the progression of how I did it. Oh, I have to explain one more thing about the progression, is that after I combine them, the key to note is that, not including the ones, you can just you have to take at most one of these bit masks. So basically, for example, if you have 5 3s, you have to choose between one of them. So that this is a simple multiplication, and of course, you can do some math to make sure that this doesn't go over mod, but it should be good because this is only 10 to the 5th. Yeah, this is only 10 to the 5th, and this fits in int, so this should fit in int as well, and you just mod it afterwards. But yeah, again, you can watch me solve it live during the contest. It's Larry. Okay. 7 people already finished this, and I'm 10 minutes of penalties, so this is not great. How far behind am I? Okay, let's refresh. Nums if product of good if the product of one or more distinct prime numbers. We don't want good subsets, not good subsets, because if it's product of one or more distinct prime numbers, what does that mean? Okay, mod. How much penalties do I have? Yikes. Okay. There are a lot of wrong answers on this one, so I have some time to catch up, but I'll probably just said something wrong, so it's fine. Okay, so the length is 10 to the 5th, but the numbers are only up to 30. So this is an interesting one. If its product can be represented as a product of one or more distinct prime numbers. What does that mean? That English is kind of hard for me to parse in the morning. Product of 6, okay. Why is this not a good subset though? It's a product of one or more distinct prime numbers. This isn't this the product of at least one prime number? I don't get it. Two and three, okay, 3, that's fine. Yeah, why is 4 not good? Yeah. I mean, this is going to be some dynamic programming with bit masks, I think, to be honest, but or something, some variation of that. But two subsets are there. The product of one or more distinct prime numbers. Okay, I guess this is not distinct is what they're saying, because 4 is 2 times 2. They could phrase that in a more like English way. I think the distinct does a lot of work here. Okay. How many primes are there under 30 or 30 or, well, I guess I was gonna say 30 or less, but there's no 3, so there's only, let's see, there's only 10 primes under 30, so it is I was going to write something, but I'm just going to copy and paste it. So these are our primes, and then now how do I want to think about this? This is doable for me, probably, but I have to think about it a little bit slower. So okay, does sorting help? I guess it doesn't change anything if we're just doing that, but so that means that we're trying to think if so there so each number here, how do I think about this, will contribute, but the ones are kind of confusing. But okay, so that means that we, for each one, we have, so it's 2 to the, so for each number we do 2 to the 10. Is that fast enough? Yeah, okay, I think so. What's 2 to the 10? 1,000? What's 10 to the 5th? Maybe not. 10 to the 5th times 1,000 is 100 million. A little bit of a sketch in Python. I wish they have a big, I mean, it should give you a big answer, but that's fine. Let's see. Like n doesn't even have to be 10 to the 5th though. I don't know why they do it this way. Is there a smarter way? 100 million is pretty slow in Python though. I don't know. I don't feel comfortable doing it in Python if this is the solution. Maybe there's a better solution though. That's why I'm trying to think a little bit. But I think this is a easy solution. Easy for me. I write this in Python anymore. On 1, 2, 3, 1, 2, 3, 1, 2, 3. Just using it and then not using it. Okay, and it's strictly. Yeah, okay. I don't even know if this is the correct language thingies. 2 to the 10. So yeah, I haven't done Java in a while, so that's why I'm like compiling. Maybe obvious to everybody thinks, but yeah, okay. Maybe that I'm using another language construct. Okay. I think there's a for each loop in Java too, but I don't want to look it up. Okay. Okay. Is that good? It should be okay. But yeah, okay. Just doing some minor optimization. What are some no good numbers? Maybe I did this backwards. So 4 is no good. And then every multiple of 4. So 9. 4. So those are all no good. So I want something that basically means that it is only because a 6 could be good, for example, because it's just 2 times 3. But yeah, maybe I'm doing this in a weird way. Yeah, maybe I don't do it. I don't want to do that for every number though. I should pre-process this. Okay. maybe I just do it this way. So I do it manually. Okay. 27 is no good because so this is 3 times 3 times 2. And then that's it, right? And then just 25. And then everything else doesn't matter, so I shouldn't write code for this. Just to make sure this one's right though, because I'm going to eat it later if I don't. This is 2 times 2, so okay. So 4 times even 9 is too big. And 4 times 5 is 20, so okay. So yeah. Okay. No good. Yes. There may be a cleaner way to do this, but basically we just want to be able to skip we want to be able to skip this and do this thing very quickly. If this is no good, then we continue, because that means that this number can never be a part of a set if except for 1 maybe. If num sub I is equal to 1, then we do something funky, which is we double everything. Yeah, we double everything except for previous of 1, I suppose. Is 1 an answer? 1 is not an answer, right? So yeah, okay. Maybe this is of 1, not of 0. Okay, maybe that makes more sense. And then now, otherwise we look at the contributions. Okay, mask on, mask off. I need to. Okay, actually no, that's fine. Oops. So the mask is okay, and then now we just do this again. Oops. I need to put this in a constant somewhere. Because I feel like I'm going to have a typo somewhere. Okay, then now if previous of j is greater than 0, that's what I need the 0 for, but but that's fine. Mask. I think this should be good, maybe. Well, I have to do this part, but so and previous and j and mask is equal to 0, then previous search mask. So I want someone like this, but we have to be clever about this because this is not gonna be yeah, this is gonna be, oh no, I think that's okay, because by the time we go to j and mask, if j is j and mask, this would not be equal to 0 anyway, so okay, maybe we're good here. And then now we just and then now we go oh wait, this is no longer, okay, I messed this up. Okay, so 0 means no numbers, not 1. Okay, that means that this is 1, then we start at 1, and then we double all the components. Okay, man, that's a silly mistake if I had held it. Now that means that this could be 0, and then I don't need to do this. Okay, and then now we just sum from everything from here. So okay. In theory, not a hard problem, but I should say that after I get this right first. Or at least get it compiled first. Okay. Is it? What is Boolean in Python? In Java? Is it just Boolean or? Like, is this right? Line 10. Okay, so this is this. Okay, that's not so bad. Prime sub I. Oh, I guess this doesn't have to be a long time ago. Well, that is unfortunate. I think how I'm doing once is wrong anyway. I think this is wrong. Let's just do continue. Yeah. Okay. Let's at least try to get it to be non-zero first, and then we'll think about it once. Why is this 0? Oh. Okay, 3 and 5. Okay. I mean, okay. So we were good except for the 1. So then now we have to do how many 1s can there be? I guess there can be as many as this, so we just have to do it every time. Okay, fine. I mean, we can actually do this in a smarter way, but for now I'm going to just do it this way. I mean, you know how to do the power math. I know how to do power math, but am I good here? Yeah. All right, let me the only thing that I am worried about is this mod stuff. I think I only do the modding here and here, so I think I'm okay. That's whew. Here goes nothing. If it's TLE, then I'll be really sad because I spent a lot of time on this one. Okay, well, I guess I should have tested this, to be honest, because I feel like that is testable. But I don't, this is only 100 million though. Like, see, it's fast enough. So it's a little bit awkward. But, but there is one optimization that I could have done, and I could have done this in Python, is that I could have condensed it. I forgot that that could be a thing. So then now we can do everything in, yeah, I could have done that. Okay, fine. Do I want to do it in Python now? I think I could do it in Python now, but how would I do this? I mean, this is doable, Larry. Just do it. So what happens if there are multiple 2s? All right, let's play it. This actually isn't even 10,000, so I don't. Okay, maybe it is. I don't know. I didn't really count. But let's just say we have this. Because I have to write answers, just that is TLE, so I could fix this. This is 41. Why is it 41? Should be just combinations of 6, right? Is this right? Because there's just 5 on this side, 5 on this. Oh, I mistyped. So okay, so there's 30 plus 11. So okay, 41 makes sense. Okay. So that means that, okay. To be honest, I also thought that 100 million should be fast enough though. I don't know, it's a little bit awkward, but okay, fine. Maybe that's what other people did too, I don't know. That's why there's so many off by, that's so many penalties. Guess we can move this here actually. Yeah, whatever, let's just do it this way. So then now I is the number. So for now, I is the number. I cannot be 0 anyway, but so 1 is equal to count up 1. Excuse me. If no I is no good. Good thing is that I already submitted, so it's okay. Oh, this is not what I want. I mean, I guess it could be what I want. So let's get the current mask, and then now this. It's this, but what does this mean? This means that we can have count number of them, right? So something like this, maybe. I am actually not confident about this one, but we'll give it a spin because the spinning is free. Spinning free, whoa. No good sub I. Oh, because we go up to. Oh, okay. I mixed up how I wanted to do these. And then I changed my mind. So then I now have to yeet it. Yeet it. Also, this doesn't make sense. I'm rushing a little bit too much. Slow down. I still have half an hour. Okay. Is this the same answer as before? And now except for it's really fast. I actually don't know. Oh wait. Oh no, this gives me a time limited. Okay, so but this is right. So let's see. Nope. I know I'm spending a couple of minutes here, but at this point, the extra time doesn't really matter. I don't think. I'm not going that fast. Is my point. Actually, I don't know if this gets copied, but okay. There should be a copy button here. Okay, and then now let's just, so that's my old code, which I know works, right? Quote unquote, maybe. Just that it may time limit, but it doesn't time limit here. So are these the same inputs? Yep. Okay, except for this is much faster. Okay, am I good? Yeah, let's give it a go. YOLO. Okay. Whew. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, especially if you like talking or seeing about these contest problems in a more real time. I'll see you later. Stay good, stay healthy, to good mental health. Yeah, have good problem solving. Bye-bye.